Okay, good morning friends, this is Ashwani Singh and today I have come with some formulae for mensuration geometry. As it is again an important part of our examination. So let us go through the formulae first. All of you know it, I know. But we have to go through the formulae first and then we'll go for certain examples so that you can be well versed with mensuration and geometry. So let us see what is mensuration. We want to measure the area. We want to measure the area. We want to measure the parameter of a particular shape of a particular bounded area. So for that we are having these formulae. Formulae for general shapes: area, surface area and volume. That means we'll be talking of 2D figures, we'll be talking of 3D figures. So when we talk of 3D figures, we'll be having surface area and volume. And when we'll be talking of 2D figures, let us say circle, rectangle and so on, triangle. So it will be a 2D figure, it will be area. Now let us take this shape triangle first. So its area is equal to half base into height. So if we are given a triangle in which we are having a side as A, another side of B centimeter, another side of C centimeter and height h, so our area is equal to half base into height if height is known. And here we can find out the height, but from the examination point of view again, if I want to find out the area without having the height but all three sides are known to me, then I will be using this formula. So this formula is a Hero's formula and it is equal to under root S minus A, S minus B, S minus C. And what is S? S is a semi-perimeter. What is the perimeter? Perimeter is sum of all the sides of a triangle. So the perimeter in this case will be A plus B plus C. Then what will be the semi-perimeter? Semi-perimeter will be A plus B plus C upon 2. So we are putting over here, so A is equal to under root S minus A, S minus B, S minus C. And this is known as Hero's formula. Correct? This you need to remember. See, mensuration is all about formulae. Now another formula for area is equal to R into S. Again, S is a semi-perimeter and R is the in radius. I'll talk of in radius when I'll go for this geometry part. So I'll tell you what is in radius. But for the time being, you take it, consider it as in radius only. In radius is actually if we are having a triangle. If we are having a triangle and if I am having a certain point through which I can draw a circle that touches every side at certain place. So this radius is called in radius and it is denoted by small r. So area is equal to RS. It is again another formula for finding out the area. And next is area in terms of the sides and the included angle. So if we are having a triangle like this over here, we are having a side A, B, C. The angle opposite to the side A is capital A, opposite to B is capital B and opposite to C is capital C. So area is equal to half AB and included angle. So AB and included angle is C. So half AB sine C, half BC sine A, half AC sine B. Correct? Then again another formula in terms of circumradius. So R is equal to A is equal to ABC upon 4R, where A is the area. This A is a side, B is one side, C is another side, upon 4R. R is a circumradius. So what is the circumradius now? So circumradius is if through a point I can draw a circle that will be touching these vertices of a triangle. So this radius is called capital R and it's called a circumradius. So anyway, I'll be going for it while doing our geometry part. Okay. So for now it is A is equal to ABC upon 4R. Then area of equilateral triangle. So area of equilateral triangle is equal to under root 3 upon 4A square. Equilateral triangle means all the sides are equal. A equals B equals C. So it is equal to under root 3 upon 4A square and the height is equal to half A root 3. Circumradius is equal to A upon root 3 and R is equal to A upon 2 root 3. All these are derived and derived from general formula, and the general formula is area is equal to half base into height. Now area of isosceles triangle. Isosceles means when I am having two sides which are equal, right? So this is the isosceles triangle. The area of our isosceles triangle is B by 4 under root 4A square minus B square, where B is the base and A are the sides which are equal. So you need to learn them because we need to apply them in our paper and we don't want to derive all these things. They can be derived although. Now, from these figures, I am coming to four-sided figures. So a figure bounded by four sides, it can be like this also, it can be like this also, it can be like this also, it can be any figure. So we are talking of four-sided figure. So let us take rectangle first, area for rectangle. So rectangle is, we are having length over here, we are having breadth over here, we are having the angle as 90 degree over here. So area is equal to length into breadth. And we are having a diagonal also. So for finding out diagonal, we'll be going for applying the Pythagoras theorem. L square plus B square is equal to D square. So D square is equal to L square plus B square, and area is equal to length into breadth. What is the perimeter then? Perimeter is the sum of all the sides of this rectangle. So it will be L plus B plus B. It will be 2L plus 2B. So we can write as 2L plus B. This is the perimeter. Now coming to area in terms of diagonals. So this is the quadrilateral. So area for quadrilateral is half into product of diagonals. So let us say this diagonal is D1, this is D2. So it is half into D1 into D2 into sine of angle between them. So if I am taking these two diagonals, theta 2 is over here. These two diagonals, I can say theta 1 is here. So my area will be half D1 D2 sine theta 1, or it will be half D1 D2 180 minus theta 1, that is equal to theta 2, and sine 180 minus theta is equal to sine theta. So it is half D1 D2 sine theta 1 or half D1 D2 sine theta 2. This is the area of a particular quadrilateral. So we need to remember all these things. Okay. Now comes another part. Area of a quadrilateral like this, if we are given a diagonal and we are having from opposite edges, we are having certain perpendiculars drawn from on this diagonal with height h1 and another with h2. So its area can be defined as area is equal to half into diagonal into sum of perpendiculars from opposite vertices. So 1 by 2 into diagonal is D, into this side is h1, this side is h2, so half into D into h1 plus h2. Correct? Now let us come to another figure, that is a parallelogram. So what is the parallelogram? In which we are having the sides parallel. So this side is parallel to this side is parallel to this side. It is a parallelogram. So area of a parallelogram is twice under root s minus a, s minus b, s minus d. And then you can see over here, if it is a, it is b, we are having a diagonal as d. So area of parallelogram is twice the area of this triangle. And triangle area we already know by Hero's formula. So it is the same thing over here. So area of parallelogram is twice under root s, s minus a, s minus b, s minus d, where d is the third side. Correct? Okay. And what is s? S is again the semi-perimeter, that is equal to a plus b plus d upon 2, that we have already discussed. So area now, if we are having a quadrilateral like this, a parallelogram like this, we are having a side a, another side is b, and we are having an angle that is equal to q. So our area will be a into b into sine of included angle. So it will be ab sine theta. It is important again. Okay. Now another property. Diagonal 1 square plus d2 square is equal to square of all the sides, sum of square of all the sides. So d1 square plus d2 square is equal to a square plus b square plus c square plus e square, where a, b, c are the four sides. But we know a is equal to c and b is equal to e, so we can say d square plus d1 square plus d2 square is equal to twice a2 square, a square plus b square, because we are talking of parallelogram. Now coming to another figure, that is equal to a rhombus. So we can see a rhombus over here. So rhombus is a figure in which we are having all four sides which are not a 90 degree, but they are equal. They can be tilted to some angles, right? So it can be like this also. This side, this side, this side, this side equal to equal to the rhombus. Right? All the sides are equal. So area for rhombus is half into d1 into d2 into sine theta, because theta is the angle between these two diagonals, and diagonals intersect at 90 degree, so that is equal to sine theta. So area for rhombus is equal to half into diagonal 1 into diagonal 2 lengths, and it is equal to a into b into sine theta, right? So we are having a side as a, another as b, and we are having theta over here. So it is ab sine theta. It is same as this one. You can see the mapping. Okay. Now square. Area of a square is equal to a square if a is the side, and it is equal to half d square also, because we know if this is the figure this is A, this is A, this is D. So what is D square? D square is equal to 2A square. D square is equal to 2A square, and half into D square. That means half into D square will give me A square. It is similar to this one. So it is equal to half D square if diagonal is given. What is perimeter then? Perimeter is sum of length of all the sides. So A plus A plus A plus A, it will give me 4A. This is the perimeter. What is the diagonal? Diagonal again I can find out. D square is equal to 2A square. So what is D? D is equal to A root 2. So it is over here. What is the in radius? In radius means if I am able to draw a circle like this, which will be touching all the sides of this square. So what is this R? This R comes to be A by 2. And again we are having circumradius. Circumradius means this radius which we are talking of. And this capital R comes to A by root 2. So these need to be learned by you. Correct? Okay, anyway. Now coming to trapezium. So we are having a trapezium as one of the figure in which we are having two sides which are parallel and two sides which are non-parallel. So A, B are, let us say, parallel sides of different length. It may be of different length, it may not be of different length. And C and D are non-parallel sides. So area of a triangle is half into sum of parallel sides into height. Okay. So half into sum of parallel sides into a height. So half into sum of parallel sides into height. It is written over here. Now, another formula for finding out the area is A plus B upon K under root S minus K, S minus C, S minus D. So what is this S? What is this K? What is this C? We'll see it. We'll look at it. So A and B we already know. We already know C and D. We are left with K. K is the difference between the length of the parallel sides. So K is equal to B and A. Difference between B and A. It is always positive. So K is equal to B minus A. And what is S then? S is equal to K plus C plus D upon 2. So S is equal to K plus C plus D upon 2. And now the formula for A is A plus B upon K under root S minus K, S minus C, S minus D. Correct? So again this need to be remembered. This is important. Now area of a hexagon. It is very simple. What is the hexagon? It is a regular figure. It is a regular polygon with these sides. And if I join these like this, so I am having 6 equilateral triangles. And let us say the side is A. So I will be having area that is equal to 6 times the area of a particular equilateral triangle. I know the area of equilateral triangle is root 3 upon 4A square. So these are 6. So 6 into root 3 upon 4A square. Correct? Now coming to another figure. Circle. So area of a circle is a pi r square that you already know. And what is circumference? The length of this rope is the circumference, and it is equal to 2 pi r. So area of a sector. What is sector then? This is a sector, that is a pi, that is a part of this complete circle. And this angle is theta. So area of a sector is pi theta upon 360 into pi r square. And what is the length of arc? This is arc. This is arc. So length of arc is equal to pi upon theta upon 360 into 2 pi r. Simple. Area of ellipse. So ellipse you all know. It's like this. Its shape is like this, egg shaped. We are having 2 axes. One is A, another is B. Right? So area of ellipse is pi into A into B. This is A and this is equal to B. So area of ellipse is equal to pi into A into B, and perimeter is equal to pi into A plus B. This you need to remember for ellipse. Now, after talking about 2D figures, let us come to 3D figures. So we are having a cube. So cube is a figure in which all the sides are equal. So what is the surface area? So surface area is, this is a cube in which we are having all the sides is equal. Right? So this is A, this is A, this is A. So the area of one surface is A square. We are having 6 surfaces. So surface area of a cube is 6A square. And what is the volume? Volume is equal to length into breadth into height, and that is equal to A cube. Now surface area of a cuboid. Cuboid means where length can be different, breadth can be different, height can be different. So we'll be having surface area as twice LB plus LH plus BH, and volume is equal to L into B into H. Correct. Next shape that is often asked is cylinders. Very frequently asked is cylinder. So what is a cylinder? Cylinder is something of this sort. This is a figure that is a cylinder in which we are having a surface that is a curved surface, plus we are having two plane surfaces, one over here and another over here. So in this case I can have two surface area, one is curved surface area and one is total surface area, that means including these two ends also. So if I am talking of curved surface area, it is that simple. I take the perimeter of base into height. What is the perimeter of base? It is 2 pi r because it is a circle, 2 pi r into height. What is volume? Volume means area of the base into height. What is the area of the base? It is pi r square. And what is height? It is equal to h. Then what is total surface area? Total surface area means it is curved surface area plus pi r square plus pi r square. So it gives me 2 pi r h plus 2 pi r square. Coming to a cone. What is a cone? It is this shade of shape. You have had many ice cream cones. So again I will be having a curved surface area and I will be having the surface area over here. So if I want total surface area, it will be curved surface area plus the area of the base. So curved surface area is equal to pi r L. I am talking of this curved surface only. What is L? This is L, that is the slant height. So pi r L. Or I can say from this part, what is L? If I am having height over here, r over here, so L is equal to, L square is equal to h square plus r square. That can already be found. So this curved surface is equal to pi r L, right? And what is total surface area? Total surface area is equal to pi r L plus pi r square because we are having a circle at the bottom edge. What is volume? Volume is 1/3 of pi r square h. Pi r, 1/3 of pi r square h. That is 1/3 of volume of cylinder. Now coming to another shape, that is a sphere. Again it is very easy. The surface area of a sphere is 4 pi r square and the volume is 4/3 pi r cube. That you need to remember. Then if I cut this sphere into two halves, so it will be a hemisphere then. So talking of the hemisphere, again we will be having a curved surface area and we will be having a total surface area if we include the area of this base. So curved surface area is equal to 2 pi r square, and what is total surface area? It is equal to 2 pi r square plus pi r square, and that gives me 3 pi r square. And what is the volume then? Volume is the half of this sphere, that is equal to 2/3 pi r cube. Coming to very important shapes now, another one is prism. So what is prism? It is this sort of structure in which I am having at two ends similar polygons, same polygons of n sides. So now again we will be having a lateral surface and we will be having two plane surfaces. So what is lateral surface area? It is perimeter of base into height. How will I found perimeter? Again it depends upon the shape of polygon which is there. It can be a triangle, it can be a rectangle, it can be a rhombus, it can be anything. So lateral surface is equal to perimeter of base into height. And what is the volume then? Volume means area of base into height, right? The funda remain the same. Then what is total surface area? Total surface area is lateral surface area plus area of these two ends. It is given over here. Now comes pyramid. So what is the pyramid shape? We are having certain base. It can be triangle, it can be rectangle, it can be any, and all these edges are coming to a particular vertex, right? So this is a pyramid. You have seen the pyramids of Egypt. So we'll be having a slant surface area and we'll be having a total surface area. That means including this base also. So slant surface area is half into perimeter of base into slant height. So half into perimeter of base, we can easily find out perimeter into this is slant height h, right? It is sh, you can say slant height. What is total surface area? Total surface area equal to slant surface area plus area of the base. Again area of the base we can easily find out because it is a regular figure. And what is the volume? Volume is 1/3 of area of base into height. So volume is 1/3 of area of base into height. That is very easy. So regarding prism and pyramid, they are important from examination point of view, and I will show you the examples also, and we have to learn all these formulae, correct? So they need to be learned before proceeding to any of the exams. So in next lecture I'll give you those topics, or I'll give you the examples and how to do them. Thank you.